In this tutorial, I will talk about different types of statistical analysis and their objectives, and the discussion will highlight types that are common in management research. I will finish with short discussion of ethno statistics and how it affects the type of analysis you do, the way you do it, and the presentation of your results. Considering the purpose of the analysis, in management research there are two broad types of statistical analysis: descriptive statistics and hypothesis testing. Descriptive statistics provides numerical data that illustrate features of your population and summarize the findings. For example, data that shows what an average is in a given population. In management, we tend to test hypotheses looking for differences, associations between variables, and prediction. We also tend not to use inference, and I'll talk about it in a second. So, in general, there are 5 types of statistical analysis. Descriptive statistics, which looks for characteristics of the population. An inferential analysis, which aims to extrapolate the values found in a sample to the values of the population. For example, if you use inferential statistics, you may want to estimate from a sample of households what an average household income in a population is. Inferential statistics is typically found in large descriptive surveys, and it's very rare, if not at all present, in management research because of our emphasis on analytical surveys. There are 3 types of hypotheses that we typically might test in management. Test of differences confirm whether a difference exists, for example, whether males are different from females. The second type of tests of associations, show if a construct is associated with another construct, for example, whether motivation is associated with performance. Finally, in predictive analysis, we aim to predict values of one variable based on a different variable. For example, we might want to predict what your performance would be if you spent a particular amount of time on study. The bulk of hypotheses in management are predictive hypotheses, and the bulk of statistical analysis concerns predictive hypothesis testing. But descriptive statistics is also frequently used, and it occurs in 2 contexts. Firstly, at the end of data collection, descriptive statistics is used to summarize your data and describe your sample. Also, descriptive statistics is typically used to illustrate properties of your variables. Let me show you an example of this. Here is an image taken from my published article that we've seen in previous tutorial. As you will see in a section that discusses measures, you will also find descriptive parameters for my research variables, in this instance mean and standard deviation for individual items in my questionnaire. One feature of management research is that it tends to deal with multivariate techniques. As mentioned earlier, analytical surveys are full of variables, frequently including 100 and more questions. The analysis of questionnaire data tends to employ multivariate techniques, that is, techniques which can handle large quantities of variables. The type of technique you may use depends on the type of research question you have and on your research design. It further depends on the type of your dependent variable. If you are thinking of carrying out multivariate data analysis, then my recommended textbook is Hare et al., because they provide an excellent illustration of a decision tree for selecting techniques that match research question and variable types. Here I present just a rough picture. When you are interested in prediction of dependence relationship that is typically found in hypotheses, then you choose a dependence techniques, and multiple regression is one such technique, and so is structural equation modeling. When you are looking for interdependence of variables, for example, you are trying to discern a pattern within data or summarize data, then you select interdependence techniques such as factor analysis, for example. Once more, for more information, I will refer you to Hare et al., who present a really excellent treatment of this issue. I will finish this tutorial with the word about ethnostatistics. Despite popular wisdom that statistics is a universal subject, different disciplines use different aspects of statistics and they use technique very differently. For example, the types of statistics that you will find in medicine varies greatly from techniques in economics, that yet again vary from techniques that you will find in management. The differences concern the type of technique used, the type of data that we use, and the parameters that we apply to determine the quality of the analysis. Typical techniques in marketing are different from those in HR or strategy. What is considered important to report and how the results are presented also differs between subjects and journals. As researchers, we tend to stick to our tribe and we behave and follow the examples of our fellow tribesmen. Let me explain this principle of ethnostatistics, that is, statistics that is found with a particular research cultures, using the example of structural equation modeling. Here is the first ever structural equation model presented by Wright in Journal of Agricultural Research in 1921. This is where it all started. Here is another example, this time from Contemporary Psychology and McCardle article from 2009. And finally, here is a contemporary example from marketing and Thompson's treatment of human brands, published in Journal of Marketing. An academic tribe chooses the techniques, chooses what aspects of analysis are being presented and reported, and what rules of presentation should be followed. The academic tribe dictates what is considered good or bad quality. My advice is, if you embark on multivariate data analysis, is to have a good understanding of the audience you are writing for and the type of journals you are likely to publish in. In other words, beware of the rules in your tribe. And with this positive thought, we will move on.